Good day, I'm Ricky Pan from GEOTECHNICAL. Today I'm going to talk about the marine deep cement mixing with the cutter saw mixing technique. In recent years, deep cement mixing was widely used in Hong Kong as the ground treatment method for many infrastructure projects. It is a non-dredging method by injecting cement slurry into the ground and mix with the in-situ soil. Cutter saw mixing, or geomix, is a type of deep cement mixing method. It was developed by GEOTECHNICAL based on the hydrophase cutter technique used in the construction of diaphragm wall. This method is quiet, low vibration, and with minimal spoil return. This type of ground treatment can shorten the stabilization time as well as to reduce the residual settlement and to facilitate the earliest commencement of the topside construction. The CSM tool is mainly composed of three main elements: cutting drums powered by the hydraulic motors, cutting blades, and the scrapers. When a drum rotates, the fixed scrapers interact with the cutting blades and shear the soil to facilitate the mixing process. Depends on the cutter size. The CSM treated panel will form a rectangular shape of 2.8 meters long and various thickness. In general, there are two types of CSM panels: individual panels, which are mainly for load transferring purpose, and continuous panel walls, which are designed to have better stability against sliding and overturning, and normally apply to the seawall portion of the reclamation. This is a classic V-shaped graph describing the standard procedure of a CSM installation. The whole installation was divided into two stages. After the cutter was positioned at the design location, it starts with the penetration stage by rotating the cutter wheels and injection of seawater to destructurate the soil. After reaching the panel bottom level, the cutter wheel will be rotated in an opposite direction and mixed with the cement grout injection all the way up to the top. In 2020, GEOTECHNICAL has successfully completed the biggest size of CSM project ever, with over 92,000 numbers of marine-based CSM panels, which was equivalent to 5.1 million cubic meters of treatment. In this project, with respect to the site-specific condition, the marine-based CSM rig was designed to work in a low headroom condition of as low as 6 meters high. The rig is flexible in height and compact in size, and fast in production as no connecting of drill rods was required. By extending the length of the hose belt and cable wires, the CSM rig could reach a depth of 60 meters or below. At peak, there were 16 numbers of low headroom CSM barges working simultaneously on the sea, day and night, 24 hours non-stop. Quality control is essential for a project success. Inside the operator's cabin, a controlling system of the CSM rig works perfectly with the onboard computer dialog to give control and monitor all the CSM construction. On the dialog screen, all the preset working parameters are shown in visualized graphs and figures to facilitate the working and monitoring purposes. In addition, an independent monitoring team at head office was assigned to have a real-time monitoring through a remote software and to give advice and support to the barge in charge during the whole CSM installation process. Data was automatically transmitted to the cloud storage, and completion reports were generated there and checked before submission. Unlike the traditional dredging method, CSM technique was a more environmentally friendly method. Along with the capping sand blanket layer, seal curtain system, and the real-time water quality monitoring equipment, the pollution of water quality and other environmental impact were greatly minimized. Also, with the use of slag cement, the carbon footprint for the whole project was significantly reduced. In addition, a team of mammal watching engineers were well trained to spot and identify the existence of the dolphins. Besides the ground treatment for the reclamation works, there are further applications of CSM, such as soil improvement for TBM break-in, mitigation of liquefaction hazards, retaining walls with steel edge inserted inside the geomix, and cut-off walls by reducing the permeability of the mixed soil, and providing effective water cutoff. That's the end of my GED talk. Thank you.